this is it. Okay, last one, topic 13, transformation. So this is what we've just been doing in school. So hopefully this is like fresh on our minds. This is great. So we have 3 different types of transformations. We have a translation, which is like a slide, where we just slide the shape around. We have a reflection, which, is like, you can think of it as like a mirror, literally reflecting over a line. And we have a rotation. And the thing about rotations is if it doesn't say which way, if it doesn't specify, we assume counterclockwise. So like that way. Okay, back to this for a second. Okay, so translation, you'll see the rules often given like this, like x plus 1, y minus 2. So just remember x is like left and right, and y is up and down. So this rule that we've done right here, a positive movement for x is like this is right, 1. And then a negative movement in y, that means down 2. Okay, so we have to watch out. Remember, x is left, right, y is up and down. Just like that, we can actually use this same key over here. Just kidding, don't use that. To remember that when we do reflections, it'll often be like, it'll give you a line of reflections. So it'll say like reflect across, like x equals 4. And if it just gives x equals number, that's straight up and down. If it gives you y equals a number, like y equals -2, that's side to side, like down 2. I'm going to make that a different color. And remember that it has to be like equal distance. The point and the image is like an equal distance away from that line of reflection. Okay, and then rotation, if it doesn't specify, we go 90 degrees. Here's this little table that we worked out before, so you might want to like take a screenshot of that or something. That could be helpful for the rotations. So here's clockwise. Here's the same rotation but counterclockwise, right? Because if you don't turn, it doesn't matter which way you don't turn it. If you turn it 1 turn clockwise, that's the same as 270. Like, one more thing we could say, like 90 degrees is 1 turn, 180 is 2 turns, and 270 is 3 turns. Okay, and we have that little key. So that should be everything that we need. Just with the translations, reflections, and rotations. So we've just been working on this. I wanted to show you what it's going to look like on the Big Ideas Math. So when you open up the practice on Big Ideas Math, this is like what problem 1 looks like. So I'm going to show you how to work this. It like has the graph. So it says graph triangle XYZ with vertices x is 2, 3, y -3, 2, and z is -4, -3, and its image after the translation, and then gives you the translation. So first it asks you to graph the triangle. So you have to graph this on its own first. So 2, 3 is like right, 2, up, 3. And if you click here, it'll put a dot on it for you. So that's x. And now we're going to put y. So y is at -3, 2. So I have to go left 3, up 2. And it will automatically draw that line. And then we're going to go to z, which is at -4, -3. So I'm going to have to like zoom out a little bit. Okay, -4, -3. So -4, -3 is over here. And it connects there. But we're supposed to get a triangle. So we just landed over here. We have to connect it back to the first dot. So you'll have to click back on the first dot to like complete the triangle, and then it shows you. So that's the original triangle XYZ. Now we're going to have to graph its image after the translation. XY goes to x, y plus 2. So since it's just x after the arrow, we're not going to move it left or right at all. This is just an up 2 because we have y plus 2. So we have to move each one of these points up 2. I'm going to start with the furthest one to the left. That one's going to go up 2, and this one here is going to go up 2, and this one up here is going to go up 2. And then I have to connect it back to the beginning. So the lower one is the original one. The top one is the finished one. Okay, so that's how you have to draw it. Just remember you have to connect it back to the original one, and then you can still hit check and everything. Same thing for number 2. This is going to be a right 4 and up 1. right? And you have to graph the original one and then the image, graph the polygon and its image after reflection in the line x equals 4. So they gave you the picture. You're going to recreate the picture down here. So that's like over 1 up 2, and then over 3 up 4, and then over 5 up 1. And then connect it. And then you're going to have to reflect it over the line x equals 4. So the line x equals 4 is straight up and down at 4. I wish I could draw it on the page here for you, but I can't. So it's straight up and down at 4. So for instance, this rightmost point, if we reflect it over the line x equals 4, it's currently 1 to the right. Ooh, uh-oh. Okay, well, if you mess up like I just did, you can hit reset. Oh, nice. Okay, so it kept that one polygon. So don't touch that one or else it'll think you're touching it. So this one over on the right is 1 to the right of the 4 line, so it's going to end up over there when we reflect it across. This one that's at 1, 2 is 1, 2, 3 away from the line at 4, so I have to go 1, 2, 3 past it. And then this one up here is 1 past it. It's going to end up right there. So that's what it will look like when it's reflected across the line x equals 4. Okay. Same thing here, so you have to graph it first and then reflect it across the line y equals 3. That's a side-to-side line that's up 3. After the glide reflection, so you're going to graph the original triangle and then translate it to up 3 and then reflect it in the y-axis. Remember, y-axis is the up and down axis. Rotate, so if I were you, I would probably draw that original one and then maybe use the shortcut to figure out where the ending point should go and put them on. Or our little table. Same thing with that one. Use the table. Determine whether the figure has rotational symmetry. So when you're deciding whether it has rotational symmetry, it's like we could split it into 5 slices, right? We could split it into 5 slices. In fact, let's do this one together. Watch this. Take a screenshot and then I'm going to clip it out of here. And then, how did I do this? Oh, I'll just copy that to the board. And let's go over to GoodNotes. And I'll just paste it on here. Okay. Okay. Determine whether the figure has rotational symmetry. So it will have rotational symmetry. We did some of these like on the smartboard, like the last day that we were in class, I think. So we just had to figure out how many slices we would cut it into. So like if we split up into slices like this, that's 1, 2, 3, 4, 5 slices. And all the way around on the inside is 360. So each slice is 360 divided by 5, which is, what's 360 divided by 5? Okay, Google. What's 360 divided by 5? The answer is 72. Okay, so we get 72 degrees. So each one of these little slices is 72 degrees. So it says, yes, let's see. So we want rotations of 72 and 144 about the center map onto itself. Yeah. Okay. Yeah, okay. That should be fine. Ha, yeah, okay. I was right. Ha, you didn't see that. Okay. Is it going to go all the way down here? Okay, so we got that one. If you're paying attention, good job. Describe a congruence transformation that maps this onto this. So you want to graph the original graph and then this second one and see how you would get to it. Let's just show the answers here. So over here, so it's, you have to reflect it across the y-axis and then, oh, I forgot what it said. Uh-oh. Y-axis and then 3 units down. So if you're watching the video, here's the answer number 9, y-axis and 3 units down. And if you're not watching the videos, sucks to suck, Okay, tell your friends to watch the videos. What is the angle of rotation that maps h onto h prime? We talked about this in class also. So 67 degrees is that inner rotation. We just have to multiply that by 2. 67 times 2 is 134. So it's just 134 degree rotation. Okay. All right, that is the last one, guys. You got this. I cannot wait for us to come back. But we just one day at a time. So good luck.